continuation with the application of dimension. Today we will discuss one application also, and that is to convert a physical quantity from one system to the other. That means if you want to convert one system to the other, then how we are going to use the dimensions. And do you know, it's very simple. When the magnitude of physical quantity remains the same, say we know that 1 kg is equal to 1000 gram, that we know. So that means a quantity is written as N1U1 equal to N2U2. Already it has been explained. And we know that U1, U2 are the units and N1 and N2 are the magnitudes. They are the values. N1 and N2 are the respective values. So we can find out it. Say we want to find out N2, we can find out it as N1 U1 by U2. And maybe 1 kg equal to 1000 gram, the dimensional formula remains same for any quantity. That is, if we say m to the power a, l to the power b, t to the power c, a general form, the dimensional will be same. So can I write it like this? N1. For U1, it will be M1 A, L1 B, T1 what? C. And for U2, it will be what? M2A, L2B, T2C, because the dimensions will be same. Okay, so can we write it like this? M1 by M2, A, L1 by L2, B, and T1 by T2, C. So we can easily use this method to find out the value of either N2 or N1. Because the dimension is going to remain what? Same, kg and gram. The dimensional formula we know it is mass. Same is force. MLT minus 2, it may be in dynes, but this is the way we are going to follow. So quantity N1U1 equal to N2U2. We want to find out N2 say, so N1U1 by U2, and then this can be written in this form. ABC will be same. Now for this application, I am going to give you one example. Say the question comes, directly there is an example. Convert 1 joule into CGS units. Now all of you know that joule is actually the unit of what? The unit of energy. Okay, so all of you know that it is the unit of energy or the work. So what is work? It is the form of energy. We know that work is force into displacement. So MLT minus 2 into L. So the formula we know ML is square T minus 2. First of all, we should know that joule is. Okay. Now N1 is given 1. You have to find out N2. Okay. N1 is in what? SI. N2 you have to find out in what? CGS. So very simple, N2 U2 will be equal to N1 U1. So what is the N2? You know that N1 U1 by U2. And can you put what? N1 1? What is U1? Again you know M1 by M2, A, L1 by L2, B, T1 by T2, what? C. Okay. Now U1 is in what? SI. So what I will write M1 in place of M1 1 kg, in place of M2 1 gram, CGS. What is A? 1. In place of L1 what I will write? 1 meter. In place of L2 what I will write? 1 centimeter. What is B? 2. In place of time what I will write? 1 second. Time will remain same. Power minus 2, because A is 1, B is 2, C is minus 2. Are you getting it or not? So I'll put it like this. Can you find out N2? Yes, 1. Now 1 kg can be written as what? 1000 gram. Okay. 1 meter can be written as what? 100 centimeter square. Okay, and 1 will cancel out, it will not be here. So simply it will be what? 1000, then it is what? Centimeter, then it is 100 square, then 1000, and then it is 10 to the power what? 4. So it is 10 to the power 7. So n to 10 to the power 7 CGS units. Or we can say that N2 is what? 10 to the power 7 ergs. So erg is the unit what? It is the unit, CGS unit of what? The work or the energy. So very simple how you convert 1 joule into CGS unit. So this is the way we are going to use for the conversion from one to the other. Okay, can I take another example for this? So another example is that, say the question comes like this, that if Young's modulus of steel is say 19 into 10 to the power 10 Newton per meter square. Now express it in CGS units. Now CGS units. Okay. Now how you are going to do it? We know that Newton per meter square, Young's modulus. It's a Young's modulus is what? It's a force per unit area. That's a pressure. That means Young's modulus is stress upon strain. The force per unit area, force is what? MLT minus 2. What is area? L square. So what it becomes? ML minus 1T minus 2. So first of all you will see that which is given. So 19 into 10 to the power 9. So again for this the value is given, say N1. It is 19 into 10 to the power 10. U1 is in what? SI. You have to calculate N2. Okay, and then we know that N2 U2 is equal to what? N1 U1, and then simply can I write directly M1 by M2 to the power A, L1 by L2 to the power B, and T1 by T2 to the power what? C. Now what is N1? N1 is given 19 into 10 to the power 10. Okay, what will be mass? 1 kg. What will be M2? 1 gram. What is A here? 1. What is L1? 1 meter. What is L2? 1 centimeter. What is B given here? Minus 1. What is time? 1 second. 1 second. What is C given here? Minus 2. So got it? Same way. So N2 will be what? 19 into 10 to the power 10. And in place of 1 kg it will be 1000 gram. Again in the same way, 1 meter it will be 100 centimeter, 1 centimeter. Okay, power is minus 1. 1 second, you don't take it from here. So simply it will be was 19 into 10 to the power what? 10, and then 1000, and then reciprocate it. So it will be 1 by 100. So this will go. N2 will be 19 into 10 to the power 11 CGS units. Okay, but if you know the unit, you can write it. It will be 19 into 10 to the power 11. What is in place of Newton? It's dyne per centimeter square. So this is how we get the conversion. So conversion can be done from CGS to SI, SI to CGS, CGS to new units, SI to new units. So this is another question which I have explained you. So this is how we are going to solve it out. Now in some problems, you know that sometime you will get the, say, the dimension. Sometime you will get that find the dimensional formula. Though these dimensions are related from class 12. One is charge Q. Second is potential V. Third is, have you heard about the resistance? Yes, resistance R. Now these three quantities are, you have gone through it in class 10th, but now they will be in what, 12. So charge, I think all of you know how you are going to find out it. What is Q? Q is what? IT. So for Q, it will be AT. Okay. In some book, if you see, it is also written as IT. So it is 80 for current is what? Ampere, and time is T. Then comes potential. Okay, then how many of you know that work? What is potential? Work by Q. What is work? Energy, ml square T minus 2. What is Q? Now Q is what? AT. So can we write it like this? M A minus 1 L square, okay, and T minus 3. So we can write like this also. This one, this will be what? The potential. So this is charge, this is potential, and then resistance. Now resistance, this was charge. Then resistance. Resistance is what? I think all of you know. R, V by I, Ohm's law. Now already you know V is here. So we will directly can put from here M A minus 1 L square T minus 3, and then there is again what? I. I is what? A, ampere. So it will be M A minus 2 L2 and T minus 3. So this is for resistance. Though these quantities are going to be used. So most of the electricity and magnetism and optics quantity which you are going through, they will be asked in class 12th. So right now we are going to follow only the 11th quantities. So this is another thing which we have discussed. Now sometime, do you know, some of you are following the homogeneity, and some have the doubt also. Yes, the question was given one, velocity 2 by 9 r square eta sigma minus rho into g. So we have to just see that LHS correctness of the relation. So again I am just explaining you because some of you may have doubt on this, but very simple homogeneity, follow it, you keep it in your mind. What is R here? Radius. What is eta here? Coefficient of viscosity. Okay. Sigma is density of body. Rho is density of fluid. This topic will come in fluids. G is gravity. This velocity is the velocity of a ball when it follows in a viscous medium, when it follows in a honey or any. This is terminal velocity. We have to check it. So very simple. Some of you may have this doubt, but this is what velocity is what? LT minus 1. Now we are going to follow this one. What is R? 2 by 9 will not be taken. 2 by 9 is a dimensionless constant. Already it has been explained. Dimensionless constant. So R square, L square. What is eta? I think all of you, ml minus 1 T minus 1. What is sigma? ml minus 3. What is this? ml minus 3. It is what? LT minus 2. So follow it. L square, ml minus 1 T minus 1. Do you know now this will follow the homogeneity? What will be the resultant dimension? ml minus 3. Because when you subtract, right, it will be the same. LT minus, then you solve it out, and then this m cancels, and it will be L cube L minus T minus 2 and L minus 1 T minus 1, and then this will go, and then finally L will be on the upside and T minus 1. So very simple, homogeneity is followed. That means LHS is equal to RHS, same dimension. So this is how we are going to follow the this concept. Now sometime you may have a question that to find the dimension of some, say, the unknown quantity. They say there is a question that the distance covered. There is a question. The distance covered by a particle, okay, any particle in time t, in time t is given by, it is given by a relation x equal to a plus bt plus ct square plus dt cube, and they are going to ask the find the dimension of abcd. Find dimension of a comma b comma c and d. Now do you know the homogeneity? Keep in your mind that the dimension will be same. So simple. What is x? The distance. So distance is x. X is actually what? Length. So dimension of x will be what? L. Now that means a should be what? Of same dimension. That means a should also be what? L. Why? Because a and x will. Then that means bt should also have dimension what? L. So b, what will happen? L by what? T. Then L by what? T. So b will be what? Having LT minus 1. Then find out about the c. This is a, this is b. You calculate it. Then ct square will again, it will be what? Equal to what? X. Same dimension L. So directly I am writing. You will get it. C will be LT minus 2. Got it or not? Okay. And then the last one is this dt cube. So dt cube will be again equal to what? L. Then can I directly LT minus 3. So this will be the answer. So in this way, A, B and C and D, you got it. So these are the dimensions which are actually the unknown quantities. They follow the homogeneity, so you can find out it. So this is very easy to calculate the dimensions. So now there is another question. I am giving you an example. Sometime you will get it that there is an equation, given an equation. Some of you may have done it, and it was P plus A by V square V minus V equal to RT. Now it was there that find dimension of A and B. A and B. Now this is actually a van der Waals equation that will come in chemistry, but right now we are not concerned about the equation, we are concerned about dimension. P here is given pressure, V is volume, okay, R is gas constant, and T is what? Temperature. So we have to find out the homogeneity. Now P plus A by V square, V minus B. So you have to find out A and B. Do you know what will be the dimension of B? Same V. What is the dimension of volume? You know that it is L cube. So what will be the dimension of B? V minus V. It should be what? L cube. Why? It follows what? Homogeneity. Simple. Then P plus A by V square. That means what is the dimension of pressure? Pressure is what? Force per unit area. What is force? MLT minus 2. What is area? L square. So it is ml minus 1t minus 2. This is pressure. So what should be the dimension of this part? They should also be equal to pressure. So that means A by V square should be equal to what? ml minus 1t minus 2. Okay. Then A by what is V? L cube square. So it will be ml minus 1t minus 2. So finally A is L6 ml minus 1 t minus 2. And then A will be M and L6 will go here and it becomes L5 t minus 2. So this is how we are going to calculate the dimension of A and B. Are you getting it? So while you are following the homogeneity, take care and just see the question twice and thrice. You can go through the question. You will not have any doubt. So this is another type of question. Now I am going to take two questions from the exemplar also. Okay. One is this, that there is a question that if momentum P, area A and time T are taken to be fundamental quantities. We take them as a fundamental quantities. Okay. Then energy has the dimensional formula. Now you have to find out the dimensional formula. This is the question from NCERT exemplar and the options are given it is P1A minus 1 T minus 1. The option B is P2A1 T1. Okay, and then option C is P1A minus half T1, and option D is P1A half T minus 1. So we have been given this momentum P, area A, time T, and they are taken as fundamental. You can take it, and then you have to find out the energy. Do you know how we do this? This is very simple. How to solve this question? And one of the example I gave you in your assignment also for the gravity, I think, and it was based on certain factors. So we are going to, so what we do? You remember energy depends on three things. P, A, T. This is the way we start. So we remember we start K, P to the power A to the power B, 2 to the power C. Remember how to derive the expression? And then energy is what? K is dimensionless. Okay, so dimensionless constant. So we replace E by what? Their dimension. What is energy? ml square T minus 2. Okay, what is pressure? What is this? P, and then P is taken what? Pressure. So pressure, we know that already we have calculated it. That pressure is what? Force per unit area. If you don't remember, you can calculate mlt minus 2 upon L square. So it is ml minus what? 1 T minus 2. So this is pressure, but I think this is momentum given. So momentum is mass into velocity. It is a small p, so mass mlt minus 1. So for this momentum is given. So mlt minus 1 A, what is area? L square B, and what is T? What is T? Time. I think time is given, and then it will be what? T. So organize it. It will be MA, okay, LA plus 2B T minus A plus C, and that is ml square T minus 2. Do you know what you do? Compare dimensions. You compare dimensions. Remember or not? So what is A here? If you see, A is 1. If I ask you what is A? 1. What is A plus 2B? It is 2. And what is minus A plus C? It is, I think, minus 2. So you solve it out. A, you will get 1. You put it here. B, you are going to get half. And C, you are going to get what? Minus 1. Okay, then you put in first. When you put in first this thing, so that means energy will be what? P to the power A, 1. B, A to the power B, B is half, and T to the power C minus 1. Okay, so you can check it here. Are you getting it or not? Yes. So this is the answer. This is the question from the exemplar. So very simple. You solve it. Anything can be written in this form. So this can be done in this way. So this is there's another question in the exemplar which I have taken from the, that is, can you check that whether the dimensions or the pair of dimensions. So question is, which pair of physical quantities, okay, does not have same formula. So this is given here, and options are given: work and torque. Are you getting it? And then angular momentum and Planck's constant, and then it is tension and surface tension, and then it is impulse and linear momentum. So very easy. This is the question from the exemplar, impulse and linear momentum. 2 questions I have taken from the exemplar, linear momentum. This is the second question. Okay, so I am not going to calculate, and work and torque, they have the same dimension. Angular momentum and Planck constant are same. Tension and surface tension are different. Impulse and linear, because impulse is change. So the answer for this is C. Why? Because tension is a type of a force. So tension is mLT minus 2. While surface tension, you have done it in dimension. It is force per unit length. So if I put it mLT minus 2 by L, so it will be MT minus 2. So this is the answer for this. So in this way, we have done the questions related with the dimensions, and dimensions are almost finished. So we'll do some tough questions later on, but there are some limitations of the dimensions you can go through. Like limitations for the dimension are that, if I just discuss it, one is the limitations of dimensions. So limitations is that uh, one is that numerical constant has no dimension. So again you have to take it out. So numerical constant has no dimensions. This is also a limitation. Or second is trigonometrical. You know that trigonometrical ratio have no dimensions. We know that they don't have dimensions. We know that exponents, log x have no dimensions. No dimensions. Okay. And in some problems, every time you are not going to find out it. If it is more, it is dependent on more than three quantities. Like there is a formula T equal to 2 pi root I by mgl. Now you can't derive it with the help of dimension, because it has more than three quantities and more than three quantities, I, M, G, L. So can't derive it. So there are certain limitations of dimensions, and in this way dimension is finished. So go through it and you will find out that some questions you can do from NCERT also. Okay, thank you, and regularly watch my videos.